How you doing? All right, let's go ahead and get started. As we're setting up our notes, I want to draw your attention to the title of the lesson. Notice how the lesson code just says Chapter 6. This is because our textbook puts all the information that I'm wanting to give you kind of in like 2 or 3 sittings. They give it to you over an entire chapter, and I'm just like, why? This is way too long to do this. So we're going to condense down what they gave us in a single chapter, and we're going to do it in just a few days. So let me catch up to you guys here. I maybe should have done this while the announcements were going off, but this is what happens when I'm not ready. We're just going to be identifying different types of quadrilaterals. And we're going to do that by using definitions and properties that we're going to be given along the way. I think I forgot a word, don't you? Yeah, I will use. Whoops, forgot a word. All right, here we go. Let's go ahead and get started. All right, so the first concept that we have to go over is actually 2 concepts in one. It's actually 2 different concepts. We have this notion of things being concave and this notion of things being convex. And it's these 2 notions that will help us decide what kinds of polygons it is that we're looking at. The first type is one that looks something like this. Yes, it's a little pentagon, but more importantly, this is a convex polygon. And it's convex because all of the angles are less than 90. And I'm going to be very specific. Be very specific that it's all the interior angles are less than 180 degrees. Convex. So we're talking about we're talking about these angles right in here. Okay?
Just going up at the angles or what?
We don't know what angle measures they are. We don't even know if they're congruent, which is why I've got a bunch of different lines in there. But we know that whatever measures these angles inside the figure have, they're not going to be bigger than 180 degrees. The other type that we have is a polygon that looks something like this.
That's concave.
Yep, this one is indeed a concave polygon. And what's happening here is that we have at least one of these interior angles having a measure that is bigger than 180 degrees. So at least one interior angle is more than 180 degrees. It's what's called a reflex angle. We had mentioned this briefly back when we were talking angle classification. We're talking about one of these angles right here. Kind of looks like Pac-Man. Okay? So if it has at least one of those, it's concave. Okay? Doesn't have to have more than one. One is enough. Now we mentioned this because we've got some properties that we need to go over. So our properties of quadrilaterals are as follows. The first property is that all quadrilaterals have 4 sides. Doesn't seem pretty exciting. The next one is that all quadrilaterals have 4 angles. And they also have 4 vertices. Now when you add up all the angles, you're going to end up with an angle sum of 360 degrees. So our four-sided figures have four major properties, and these properties are that there's four sides, four vertices, four angles, and an angle sum of 360 degrees.
Vertex. Yes.
Oh,
Oh,
thank you. I forgot an E.
I love this photo too.
Thank you. They have four vertices. With these properties, by adding small, tiny little other properties that quadrilaterals can have, we end up with three different major classifications. And so that's going to be our next section. We're going to classify. So this is going to be our classification of parallelograms, or excuse me, of quadrilaterals by
Miss, what is that word?
the number of which one? This one?
Yeah.
Quadrilateral. Thank you. By the number of parallel sides. This is how we're going to classify the different type of quadrilaterals that we have. Please take a moment and the rest of your note-taking space here on the right, divide it into three more or less equal columns. You can either take a pencil and kind of lightly guess, or you can fold it. I'm going to lightly guess because I know some people are still copying. You're welcome to fold the paper.
What?
So you end up basically with four
Okay.
columns. Okay?
4 columns or 3
Yeah, four
columns?
columns including the left-hand
Oh,
column.
okay.
Yeah, the three columns are more or less congruent to each other.
There's three. There's three.
And there's three in here. So I'm just going to take my protractor, make these lines really neat. There you go. And yes, go all the way down to the bottom of the page because we're gonna fill up the rest of the page. All right, we have three different ways to classify these by the number of parallel sides. We can have 0 pairs of parallel sides. So 0 pair of parallel. We can have 1 pair of parallel. Or we can have 2 pairs of parallel. These are, we haven't given them the names yet, but this is kind of the main way that we're going to classify them. Yeah, we have 3 columns. When our quadrilateral or four-sided figure has no pairs of parallel sides, we're going to call that entire family of quadrilateral trapezium. Trapezium. This is an I right here. Trapezium. So take a moment,
Trapezoid.
turn to someone near you and go, trapezium, have 0 parallel sides.
That's not that trapezoid.
Yeah, 0 parallel sides.
That's trapezoid, isn't it?
He keeps saying trapezoid.
Yeah,
We're-
I know.
Trapezium.
Trapezium.
It's trapezium. And I know it's really close. You're going, what's the difference? And here's the difference. The trapezoid only has 1 pair of parallel sides.
So there's different shapes.
So they're different.
What the?
Front door.
The trapezium has no parallel sides. The trapezoid has 1.
Trapezoid something.
When both pairs of sides are parallel to each other, we call the shape the parallelogram. We're going to look at these first 2 more closely first. All right. Trapezium could be like any looking quadrilateral, but we've got a special name for one of them if it has a certain characteristic. So this name is a kite. We call a trapezium a kite if it has no pair of parallel sides and two pairs of adjacent sides being congruent. Looks something like this.
That's a kite.
That's a kite. A kite has no pairs of parallel sides. So it's a trapezium. But this specific trapezium is called a kite because the two sides closest to each other are congruent to each other. But each of these pairs are not necessarily congruent to the other pair in our figure. Okay? These kites have some additional special properties more than just being four-sided figures. So more than just having four sides, four angles, four vertices, and an angle sum of 360. Kites also have their diagonals being perpendicular, which means they're going to intersect at what angle?
90 degrees.
90 degrees. Thank you very much, sir. In addition, when you have these diagonals intersecting each other, one of these diagonals will bisect the other. Mm-hmm. All right. You're gonna wait for it, huh?
Yeah.
In suspense. Okay. She's like, no spoilers. Under the trapezoid, most of you already have an idea of what trapezoids look like. Yeah, they look like Pizza Hut signs or the top of houses or something, right? This is what you're used to them looking like. The thing is that this picture is a very specific kind of trapezoid. When we make these two non-parallel sides congruent to each other, we call it an isosceles trapezoid. And these are the type of trapezoids that you are the most familiar with from state tests and things like that.
Or in kinder.
Yeah, kindergarten is the isosceles trapezoid. Its special property is that those non-parallel sides are congruent. And it too has a special property to it, more than just four sides and four angles and all of those. The isosceles trapezoid's special property is that the base angles are congruent. Yeah, they're these. So if I'm looking at this side right here, and I call this the base, then this is the base angle, and they're congruent to each other. Bless you. If I flip it over, bless you, and I call this one the base up here, then this angle is going to be congruent to this angle. Hi, can I email? Thank you. All right. Now the parallelograms. The parallelograms, just as soon as we make sides all parallel to each other, we get a bunch of different properties, and they create three little subgroup, like baby kind of things, okay? So we're going to list all of the parallelograms properties first, and then deal with their little subsets. So the first thing that parallelograms have as a property is that the opposite sides are parallel. Not only are the opposite sides parallel, but these opposite sides are also congruent. With opposite sides being congruent, opposite angles become congruent. And those consecutive angles, the ones that follow one right after another, end up supplementary. Do you remember what supplementary meant?
180 now?
Yeah, 180. The last big property that these have is that those diagonals are going to bisect each other. And we typically draw parallelograms looking something like this. Okay, so that looks more like a rectangle today, but where the only markings are high, sides are parallel. I'll leave this up for a few moments and then we'll turn the page and we'll get into the types of parallelograms.
Miss, what's the name of the one that's like a square but it has like that?
But slanted lines?
Is that a
As a parallelogram.
It is going to be a type of parallelogram, especially if it's coming from the square little subfamily. You're about to see it right now.
Hey, Miss.
That was my question.
And we'll give you the name of that family too.
Draw a triangle. Rectangle.
It kind of looks like a rectangle, but really the only thing that you're marking is that those sides are parallel. We don't know anything more about that. And we're about to see that rectangles are a very special kind of parallelogram. Alright, I'm going to turn the page. I still have a few people copying, so in about 10 more seconds?
Yeah, I'm just on the last one.
Okay, she's on the last little drawing. Okay, if you're changing the page, please go ahead and set it up for notes.
Miss, what if you're good?
If you have room, you can stay on the same page. I have to change the page. All right, here I go. All right, this is our types of parallelograms. So these three types are not only going to have all the properties of a parallelogram, but in addition, each one is going to have something special that makes them unique. So go ahead and once again divide your workspace into 3 sort of equal spaces. You only need like maybe 4 or 5 lines total. This one was too big. To do what it is that we're going to do next. So
Miss, all I have is that one space. I can
that's
turn it.
perfect. That's perfect.
It is?
So you only need maybe 5 or 6 lines. I'm doing them in pencil. Alright, the first special type of parallelogram is called the rectangle. This means that a rectangle is a quadrilateral. It has 4 sides and 4 angles, and when you add them up you get 360. But it's also a parallelogram, so all the opposite sides are going to be parallel to each other. They're going to be congruent to each other. Opposite angles are going to be congruent. All of those things that we talked about under the parallelogram. But what makes the rectangle a special type of parallelogram is that it is the only one that has just 4 right angles. I don't know anything about the side lengths, other than what the parallelogram tells me, that the opposite ones are congruent to each other. But it has 4 right angles. Its special property is that the diagonals are congruent. So not only do these diagonals bisect each other, because it's a parallelogram, they also are congruent to each other. The next one is the one that you had asked about, Anna. What was that special name that looked like a square, but it's kind of slanty?
Oh yeah, rhombus, that thing.
It's a rhombus. And the reason why it kind of looks like a square to you is because a rhombus is a parallelogram, but it has 4 congruent sides.
Like one is 2 or slanted, right?
Well,
Or 2 parallel sides.
they're all parallel sides. So the opposite sides are parallel to each other. But the reason this thing looks slanted is because we don't know anything about the angle measures.
Oh, so it's congruent, 2 sets of congruent angle measures. That's why it looks weird.
That's why it looks kind of weird. Yeah. Now, on top of all of the stuff that you get from it being a parallelogram, rhombuses in particular have diagonals that are perpendicular. And then the last one is the square, the one that you're comparing the rhombus to a lot.
Yeah.
Now note, rectangles and rhombuses are different things, but look at what the square has. The square is a parallelogram with 4 right angles, which means all squares are rectangles. But it also has 4 congruent sides, which means squares are also rhombuses. So the square is going to have all the properties of a parallelogram, and all the properties of rectangles, diagonals are congruent, and all the properties of a rhombus, diagonals are perpendicular, all at the same time. The square is a very, very, very picky little beast. Questions on what we went over today? All right. We're done for now. Tomorrow we're going to start applying these properties. Thank you.
Let's go.